Hi everyone, thank you for coming. Thank you Android Worldwide team for giving me this opportunity. Today I'm going to talk about the cost of modularization. My name is Aldo. I'm currently working at Astro. So Astro is a quick commerce company in Indonesia where our customers can purchase groceries and essential items and will send them in less than 30 minutes. So before we talk about modularization, I think it's important to know a little bit about modularization. Modularization is the act of breaking one module into multiple Gradle modules. In this presentation, I use the term module and project interchangeably. So when I said multi-module, this also means multi-project. Okay, there are three reasons why we use modularization. First is faster build time. If done correctly, by using Gradle parallel build feature, we can achieve faster incremental and clean builds. The second reason is that modularization encourages reusability. Since the module is broken up into multiple modules, we can import a module like a library. And the third reason is clear ownerships. Typically, modularization is implemented in a company where there are many engineers. The engineers can form a dedicated team to work on a set of modules or functionality. So team A can focus on modules related to payment, team B can focus on modules related to libraries, and so on. Of course, there are implications of implementing modularization. Modularization adds complexity to our project. We should spend more time and effort to solve the challenges or the costs, as the title of this presentation. So Toys app is a project that I will use throughout this presentation to demonstrate some of the concept you'll see later on. The code sample that you'll see in this presentation is simplified. If you want to see the implementation detail, please check the code of Toys app in the GitHub repository. I'll share the link later. So the toy app has three screens: main screen, toy screen, and payment screens. From the main screen, we can navigate to toy screen, the screen in the middle, and in the toy screen, we can navigate to the payment screen. So we can navigate between the payment and toy screen. This demonstrates the navigation between feature modules that we'll discuss later on. Okay, without further ado, the cost of implementing modularization. We'll discuss what are the costs of modularization and when we'll encounter the problems and how to solve it. The cost number one, organizing modules. As I said in the previous slides, modularization means breaking down one module into multiple modules. This can happen when we start a new project or adopting modularization in the late stage of development. The problem is, if we didn't define the clear boundary, we don't know how to organize our modules. We'll encounter questions like, how many modules should we create? What's inside a feature module? Should a repository goes in the feature module? If we don't know how to organize our modules, we may end up creating too many modules. This can lead to unnecessary complexity. Or not creating enough modules so that we don't gain the benefit of modularization like faster build speed, reusability, and clear ownership. The solution to defining the boundary is to decide the app architecture and the module convention together with your team. There is no straightforward answer for organizing modules. It really depends on your project requirements, your team size, the library that you'll use, and so on. For this course, you really need to make a consensus with your teams. But in general, we can define how to organize our module by defining the app architecture. like MVVM, MVI, etc. Then we also should create a module convention like app module, feature module, library module. This helps us define what's included and not included in the module. Lastly, we should define the relationships between modules. In this presentation, I'll share the example how we organize modules. Three examples to be exact. The first example is taken from the Android developer documentation. Thankfully, in 2022, Google is giving more practical guide on implementing modularization. So as you can see in this picture, the feature module contains the view module, and the preferred app architecture is model view module. There is home view module in the feature module, home feature module, reviews view module in the reviews feature module, and checkout view module in checkout feature module. A feature module can depends on data module where the actual input output is happening. Next, the data module contains the repository. The repository can delegate the actual work to the implementation classes, the one marked internal below. In this picture, there are book local data sources that talk to database, book remote data source that communicate to the server, and payment play data source that I assume talk to the Google Play API. So this is the complete graph. From this graph, we can see that there are 4 types of modules from top to bottom. We have app modules, feature module, data module, and core module. The graph is a directed graph. So the arrow means one-way relationship. App module can depend on feature module, but not the other way around. Same thing with feature and data module. Lastly, the core module sits at the bottom of the graph, and the core module can't have dependency to the upper modules like data, feature, and app modules. Example 2 now in Android. If you're not familiar with Now and Android, Now and Android is a project that Google team used to demonstrate Jetpack Compose and most importantly, modularization. Let's see how Now in Android organize their modules. You can see the similarities with the example 1. There are 3 types of modules instead of 4, app module, feature module, and core module. And the difference is the data module is merged with the core module. I assume Now in Android team makes this decision because this app, Now in Android app features are limited. They don't need to create a dedicated data module for each feature. And if you look closely, this part, the core module can talk to other core modules as long as there is no cyclic dependency where 2 modules has dependency on each other. Of course, the last part is the Toys app. In this project, there are only 3 types of modules: app modules, feature modules, and library modules. With a caveat, the feature modules is separated into 2 types, Android and library. Since I find some of the library don't need Android framework at all, it into 2 types, and there is no data modules in this project either, because this app does not communicate to server or database. So yeah, to wrap up, we have to decide the app architecture and module types with our teams. It depends on the project requirements, the team size, and the libraries that we'll use. Cost number 2, enforcing module convention. Now that we have decided the module convention for our project, we should enforce it. When we create a new module, we need to ensure that the module should follow the module conventions. For example, if we create a new feature module, we need to make sure that it uses the same plugins, the same libraries as another feature module. Also, when we update the module configuration, the changes should be reflected in the same module type. Lastly, we should make sure the module can only depend on a certain module. We can, of course, do this manually by copy pasting the build.gradle configuration, but there is a better way by using a Gradle plugin. We can use Gradle plugin for storing our module convention. This is commonly called convention plugin. And the module itself contains module configuration like settings, dependencies, plugin, etc. To make sure the module has correct relationships, we can use this cool plugin called Module Graph Assert. This plugin is created by Joseph Raska. I hope I spelled the name correctly. Okay, how do we use this plugin, this convention plugin? First, we need to create a project to store the plugins, right? Somewhere. And let's call this project build logic. Next, we create the actual plugin. And the plugin itself is just a standard plugin that implement plugin interface. Finally, we need to register the plugin like this so that it can be used by others. Let's use feature module in the Toys app as an example. In the Toys app, the module is using Compose. Currently, there are only 2 feature modules. If you want to add a new feature module, we can configure it faster with convention plugin. Right? Let's say we have the third. There are other module types as well, like Android library and JVM library. But in this example, I'm just going to demonstrate the creation of convention plugin for feature module. This is the current feature module build.gradle, where we have plugins block, default config block, and dependencies block. Yeah, I think you guys already familiar with this configuration. We will extract this default config to compose option block first to the plugin. And as you can see from this code, it looks similar with the code in the build.gradle, right? Same default config block, same build features, and same compose option. We just have to move it to the plugin by using this extension.configure function. And after moving the default config and compose option to the convention plugin, we're left with this empty Android block. And now we just need to migrate these plugins and dependencies block to our plugin. Here, we are using plugin manager apply function to apply the plugin and dependencies block to add the dependencies. And this is the final code in the build.gradle. We just need to apply the plugin ID in the build.gradle, and our module will conform the feature module type. If we add a new code in this build, it's only to this module. If we want the changes to apply to all feature modules, modify this plugin instead. Okay, next we'll see how we can enforce module relationships using module graph assertion plugin. So from this, we can infer the following rules. The app module can depend on feature module. Feature module can depend on library module, but not the other way around, right? And to enforce these rules, first we need to set up this plugin, import this plugin. And as you can see, we are using convention plugin for our app module to add a module graph assertion plugin. We then formalize the rule we have decided in the previous two slides, where we allow the following relationships. The app module can depend on feature module. The feature module can have dependencies to library modules, but we restrict the following relationships, where feature modules cannot have dependencies to another feature modules, and Android libraries or libraries cannot have dependencies to feature modules. So yeah, let's test our rule by making the payment module depends on the payment modules, like this. In the payment feature build.gradle, we add the toys features as the dependencies. When we try to do that and execute the assert module graph, we will get an error because the feature module is not supposed to have a dependencies to another feature modules, right? And the plugin will nicely show the reasons of why this produce an error. Payment cannot have dependencies to feature toys because it's not allowed by any of the rule that we just write before. If we remove the previous code and run the task again, we'll get a successful build. Also, note that this plugin has another hidden feature that might be useful for your project. The task that can generate a module graph. Just run the generate module graph text task to create the module graph. The output will be a graphis.file. Okay, cost number 3, dependency management. Managing dependencies in a multi-module project can be tricky. If we add an external library to our project, we need to ensure that the library with a different version does not exist. Also, if we have many modules in our projects that we write our own, let's say 100 modules, it would be nice to search it quickly without worrying a typo. We can use Gradle version catalog for managing dependencies across modules. We can do so by adding libs.version.toml file to the Gradle folder. If you want to, we want modules in our project to be accessible to other modules, we can use this feature called typesafe project accessor. To enable it, add this code in this settings.gradle.kts. So this is the example of version catalog's toml file, where we have version sections, library sections, and bundle sections. You can put a library version in the version section. In the library section, we put the artifact name and artifact group and name. In this example, I want to use Compose library for our modules. We declare the Compose version that we want to use under version section and refer the Compose version like this. Version catalog also support bundles. We can bundle multiple libraries together. For example, to use Jetpack Compose libraries, typically we need to specify these 4 libraries, right? We can just refer to one bundle instead of typing these 4 libraries. And this is how you use it. To use the version catalogs libraries, just use libs followed by your library name or bundle name, like this. This example, this is the coin library, and this is the Compose bundles. Notice that the coin library definition is converted from using dash separator, like this, into dot separator. We can also use this version catalog or libraries in the test implementation scope. By using version catalog, we are confident that our modules are using the same library versions. The feature modules is using the same compose feature, compose version. The library modules is using the same JUnit version, and so on. Okay, lastly, type-safe project assessor. Type-safe project assessor is pretty self-explanatory if you look at the code before and after. If you enable these settings, you can access the modules by using projects followed by your module name. Same with version catalog, the dash separator, like this, is converted to dot separator from feature dash payment to feature payment. Ah, yeah, like this. But unlike version catalog, Gradle will generate the projects automatically. So you can use it in your module right away. You don't need to write the module definitions like this. Okay, cost number 4, dependency injection. This is a common scenarios in a multi-module project where you need an instance of a class or an interface, but the implementation class or interface is not in your module. To illustrate this problem, we have payment activity that wants to get an instance of logger. The implementation of logger, whether it's console logger or locat logger, is in another module. And payment module only has a dependencies to the logger library, not to logger or locat logger. So how can payment activity get an instance of logger? We can use dependency injection for this. I'm using Coin as the dependency injection library. The secret is, or the pattern is, to make app modules has access to all modules in the project. Since the app module has access to all modules, app module can construct the instance definition. We can create coin module in the app module, or we can create coin module in the feature or library module. It does not matter because app still has access to the coin modules. And as you can see in this graph, app module has dependencies to feature payment, libconsole logger, liblogger, and Android lib locat logger. We just need to wire them up together. And this is how you do that in Coin. First, you need to create the module in the app module, like this. Inside the module, we declare the console logger as the implementation of the logger interface. Then you just need to pass the module in the main application. Alternatively, if you are generating the module, coin module in the feature module, you can also add it like this. Right? This is an example of coin module from feature payment. Lastly, the payment activity will receive the instance of logger that will be provided by app module, like this. Okay, the last cost, and that is navigation. This is yet another common scenarios where the activity needs to call another activity and vice versa. The problem is the activity is in another module, similar to what we encountered in the previous cost. Also, if you still remember our graph rule, the feature module cannot talk to another feature module. In this code, toys activity needs to call the payment activity, but payment activity does not exist in this module. Toys module cannot declare the payment module as a dependency, since we have enforced this by using the plugin in the cost number 2. Sounds familiar? Yeah, we can use the same dependency injection technique. I call this technique intent provider since it's providing intent to the consumer, but there's another name for this. It's also called mediator modules. You'll also see why this is called mediator module in a moment. So intent provider. Remember the basics of Android development, where to start an activity, you need to provide an intent. Let's ignore this payment activity for a moment, right? If we can somehow create an intent, we can start an activity. Now, we just need a way to provide this intent. I use this interface called intent provider to get payment intent. So what's this payment intent provider is all about? This interface only has one function, get payment intent. It will return an intent, and it has two arguments, context and an arbitrary argument. In this case, payment uh, payment gateway. This intent provider class lives inside this navigation library. Both feature modules can make a dependency to these modules. By doing that, the payment intent provider will be available in both feature toys and the feature payments. And if you see in the graph, the navigation module is sit in the middle or mediate between feature toys and feature payment. That's why it's called mediator model. So the toys activity will be the one who consume the payment intent provider. Which module will implement the payment intent provider? The feature payment. That's right. The payment module will implement payment intent provider. Since payment intent feature payment has access to payment activity, we can just construct this intent by passing the activity. And then we just need to return the intent. Therefore, the intent can be consumed by the toys module. But how can the toys module get an instance of the payment intent provider? We can use, again, dependency injections. Remember that the app module has access to all modules? Well, we can define the definition of payment intent provider in the app module. In this app module, payment intent provider implementation is the implementation of payment intent provider, and this will be used by toys activity. Now, the toys activity can get the instance of payment intent provider and then can launch the payment activity. So there are other solutions for navigation. For another activity to activity navigation in a multi-module project, we can use implicit intent with a package name. To do so, just use the action name in the Android manifest file. When you call the intent, don't forget to pass the package name. Since in the Play Store we are guaranteed to have a unique application ID, we're sure that only our app can open the implicit intent. For single activity architecture using Jetpack navigation, we can use deep link. Deep link is just a string that you define in the navigation graph. In this example, I use the string called toys fragment string. This. So yeah, that's pretty much it. So when you should do modularization, when you and your team have time and effort to pay the cost, which we just covered in this presentation. To summarize, you need to organize your module by defining the app architecture and module types. Second, enforcing a module convention by using convention plugin. Third, using version catalog for dependency management. Fourth, using app module for dependency injection. And five, using intent provider for navigation. Yeah, that's all. I hope you find this presentation useful. Thank you. I will stop sharing my screen and we'll get back to Shalom.
Okay, thank you very much. Yeah, that was lovely. All right, folks, I want to give everybody a couple minutes to, yeah, good. We see some claps. If you can post your questions in the Q&A section, give you a couple minutes to write them. And then we'll get to answering them. Yeah.
Okay.
Yeah, so yeah, we'll give them a couple minutes. So Aldo, What are you up to? What are you up to for the rest of your day? Just kill some time.
Just working.
Nice.
And yeah, just working this day. By the way, Shalom, I think we have an anonymous question in the
Oh,
Q&A section. Can
feel,
I answer it?
yeah.
Yeah, so the question is regarding the Gradle modules. Is the entry point always an activity? Oh, okay. So between each modules, right? Okay. The answer is no. You see, if you are using single activity architecture, you can also use fragment to move between one module. Can fragment of one module be inflated in another module? Yes, you can. But I think you're not going to use the intent provider pattern. Instead, you should use deep link. So deep link needs to be created when in the navigation graph. So when feature A want to call feature B, you need to remember the deep link address. And when you pass the deep link address to nav controller, you can access the fragment. So it will be navigated to fragment. Okay, uh, from Mosen, modularization by feature or layer. Which one you experiment with? What about shared parts? So this day I tends to follow the guide from the Android developer documentation. So it's by feature actually. Yeah, by feature. There are four types of modules: app modules, feature modules, data modules, and common or core modules. And I find that with the guide that's provided by Android developer documentation, since it gives enough separation of concern or boundaries between modules. The feature layer can contain screens. The data layers can just inside the data layer we can put repository and network call and database call and so on. Yeah, so I would follow the guide from Android developer documentation. Okay, I want to ask the last question, but do we have time, Shalom?
Oh yeah. Go for it.
Okay. For the last question, have you tried to do dependency injection using Hilt instead of Coin? Yes, but not using Hilt entirely. Apparently, our team also need to use Dagger to do dependency injection. So it works. You can use Dagger too if you want to use modularization. Okay. Do you split each module by API and implementation? Good question. Yes, we should. Actually, there is another plugin that I didn't show in this presentation due to our limited time. Uh, I think the author of the plugin is Autonomous Apps. So the plugin will give you the advice on when you should use API and when you should implementation. By using that plugin, if you run the plugin, you'll get a recommendation for all modules in your projects. And if you follow the advice, you can use API or implementation in the dependencies block. Okay. What about navigation between modules in feature-based modularization? Yeah, so I think I covered that in course number 5. If you are using activity, you can use intent provider or mediator module to navigate between feature module or between activity.